The thermometer inside Elias Tanner's cabin read 54 degrees, while the blizzard outside howled at -32. And as he remembered finding Robert Calloway frozen in his bedroll 3 winters earlier, despite a fire burning all night, he finally understood that survival wasn't about bigger fires, but about why heat disappeared faster than any single chimney could replace it. Before we continue, drop a comment telling us where you're watching from, and if you value Forgotten Frontier wisdom, hit subscribe because tomorrow's story reveals an innovation even more unbelievable than this one. The winter of 1834 arrived in northern Wyoming territory with a cruelty that surprised even experienced mountain men. Elias Tanner had spent 6 seasons trapping beaver along the tributaries feeding into the Powder River, and he understood cold. He knew how to read weather signs, when to seek shelter, how to layer clothing for maximum warmth. But the cold snap that hit in late January of that year transcended normal winter hardship. It was the kind of cold that killed quickly and without mercy. Elias had partnered that season with Robert Calloway, a methodical trapper from Pennsylvania who had come west 4 years earlier. They had built their cabin the previous summer using standard mountain construction. The structure was solid by frontier standards, logs chinked with moss and mud, a single stone chimney that Elias had spent 2 weeks building, a heavy door, 1 small window. The cabin measured roughly 14 feet by 16 feet inside, with a sleeping loft accessible by ladder. It was typical of what trappers built, functional and adequate for survival. The cold snap began on January 23rd. The temperature dropped steadily throughout the day, and by evening, breath froze instantly in the air. Elias and Robert kept their fire burning hot, feeding it constantly. The stone chimney radiated heat into the main room, and both men felt reasonably comfortable near the fireplace. But as the night progressed and the temperature continued falling, they noticed something troubling. The cabin's corners remained bitterly cold. The sleeping loft, where rising heat should have provided warmth, felt barely warmer than outside. Cold air seemed to seep through every gap in the chinking, despite their careful construction. Robert climbed into the loft around 10 o'clock, wrapped in 2 blankets and wearing most of his clothes. Elias stayed below, maintaining the fire. He added wood every hour throughout the night, keeping flames high and constant. The stone chimney stayed hot to the touch. By any reasonable measure, they were doing everything right. Elias woke at dawn on January 24th. The fire had burned down to coals, but the chimney still radiated stored heat. He climbed the ladder to wake Robert for the day's work. Robert didn't respond to his call. Elias touched his partner's shoulder and knew immediately something was catastrophically wrong. Robert Calloway was frozen solid. Elias pulled back the blankets with shaking hands. Robert had died sometime during the night from exposure in a heated cabin with a fire that had burned continuously. Elias checked the thermometer that kept hanging near the door. It read 16 degrees inside the cabin. Outside, the temperature had reached -40. He spent that day in shock, unable to process how a competent man could freeze to death inside a structure specifically built for warmth and protection. Elias buried Robert on a hillside 2 days later when the ground thawed enough to break with a pickaxe. He marked the grave with stones and stood there long after the work was finished, trying to understand what had killed his partner. The answer everyone would give was simple: the cold. But that answer felt incomplete. Men built cabins specifically to survive cold. They built chimneys and fireplaces to generate heat. Robert had died, despite every precaution, inside a structure designed for exactly the situation that killed him. Something was fundamentally wrong with how mountain men understood shelter and heat, and Elias became obsessed with discovering what that something was. Most trappers would have mourned their partner, accepted the tragedy as part of frontier life, and moved on. Elias couldn't move on. Every time he sat near his fireplace, feeling warmth on his face while cold air pooled around his feet, He thought about Robert freezing in the loft above a heated room. He spent the remainder of that winter visiting other trappers' camps within traveling distance. He invented reasons for these visits, claiming to trade supplies or share news, but his real purpose was studying their cabins. He observed how they built fires, where they positioned sleeping areas, how heat moved through their structures. He asked questions that made men uncomfortable. How cold does your cabin get at night? Where do you feel coldest? Do you wake up cold even with the fire going? A pattern emerged quickly. Every single chimney cabin, regardless of construction quality, suffered from the same problems. Heat concentrated near the fireplace while distant areas remained dangerously cold. Sleeping lofts, where men logically positioned their beds to capture rising heat, were only marginally warmer than ground level. Corners became cold traps, where air seemed to freeze and stay frozen. Most critically, even well-maintained fires couldn't keep cabins warm enough during extreme cold because heat escaped faster than it could be generated. Elias started paying attention to smoke behavior. He noticed that when fires burned hot, smoke rose through chimneys efficiently, but that same draft pulled cold air into the cabin through every gap and crack. The chimney that was supposed to heat the cabin was also creating the suction that brought freezing air inside. It was a closed loop that couldn't be won. Build a hotter fire, and you pulled in more cold air. Let the fire die down, and you lost heat faster. He observed air movement using candle flames positioned in different locations. Near the fireplace, flames bent toward the fire, showing air flowing into the combustion. In corners, flames barely flickered, showing stagnant air that wasn't circulating. Near the chimney base, flames bent sharply, showing powerful draft. The cabin wasn't a unified warm space. It was a collection of thermal zones, some heated, most not, with air flowing in patterns that worked against comfort and survival. By March of 1835, Elias had visited 11 different trappers' camps and studied their heating systems. He had documented temperatures in different locations within cabins. He had sketched airflow patterns and noted construction variations. Other trappers began talking about him. Dutch Henderson, a loud trapper who worked the region north of Elias's territory, started calling him the grieving philosopher, mocking his questions about heat and cold. Martin Gresham, an experienced mountain man who had survived 14 winters, told Elias directly that he was wasting time trying to understand things that couldn't be changed. The summer of 1835 brought a decision that would change everything. Elias needed supplies and needed to sell his winter's fur harvest, which meant traveling to Fort Laramie. The journey took 8 days on horseback, following established trails through mountain passes and across high plains. Most trappers made this journey quickly, conducted their business, and returned to the mountains as fast as possible. Elias planned to stay longer. He had questions that needed answers, and Fort Laramie was the closest place to find men who understood construction beyond basic frontier methods. The fort was undergoing expansion when Elias arrived in late June. New buildings were rising inside the palisade walls, and unlike typical log construction, these structures were being built with stone foundations and properly engineered chimneys. Elias sold his furs to the trading post, collected his payment, and then did something unusual. He approached the construction site and asked permission to watch the masons work. The head mason was a German immigrant named Wilhelm Kessler, who had learned his trade in Bavaria before coming to America. He was initially suspicious of the scruffy trapper who wanted to observe stonework, but Elias's earnest questions and obvious intelligence convinced Wilhelm to talk. Over the next week, Elias spent hours watching Wilhelm and his crew build chimneys and foundations. He asked constant questions about technique, materials, and principles. Wilhelm explained concepts that Elias had never encountered. Thermal mass was the most important. Stone absorbed heat slowly during the day and released it slowly at night. A massive stone structure could store tremendous amounts of heat energy and radiate it for hours after a fire died down. This was why stone chimneys were superior to mud or brick for frontier use. The weight and density created a heat battery that kept working long after flames stopped. But Wilhelm shared something even more significant during a conversation on the fourth day of Elias's visit. He mentioned that wealthy homes in Europe sometimes used dual flue chimney systems, two separate chimneys serving different fireplaces in the same building, positioned to create air circulation throughout the structure. One fireplace would heat the main living area, the second would be positioned to draw cold air from lower areas, heat it, and exhaust it, creating a convection current that moved warm air through rooms that a single fireplace couldn't reach. Elias asked Wilhelm to explain this multiple times, making sure he understood correctly. The concept seemed counterintuitive. Building two chimneys meant double the work, double the stone, double the maintenance. But Wilhelm explained the physics. A single chimney created one thermal zone. Two chimneys positioned correctly created air movement between zones, distributing heat more evenly and maintaining higher overall temperatures with less fuel. Wilhelm admitted he had never built such a system himself. It was expensive, complex, and unnecessary for most applications. But he had apprenticed under a master mason in Munich who had built dual flue systems for wealthy merchants, and Wilhelm remembered the principles clearly. Elias spent his evenings that week sketching ideas in a small notebook he had purchased at the trading post. He drew cabin layouts with two chimneys, trying to understand how the concept could be adapted to frontier conditions. Elias returned to the mountains in late July of 1835 with his notebook full of sketches and a plan that seemed impossible even to him. He selected a new cabin site on high ground near his old location, a spot with good drainage and clear sight lines. Then he began the most labor-intensive phase of his project, gathering stones for two massive chimneys. River stones were ideal for chimney construction. Water had already rounded and smoothed them, making them easier to fit together. They had been tested by centuries of freeze-thaw cycles, proving their durability. Elias needed approximately 3,000 pounds of stone for each chimney, which meant hauling 6,000 pounds total from the nearest river, located half a mile from his building site. He spent 3 weeks doing nothing but gathering stones. He selected each one carefully, rejecting stones with cracks or irregular shapes. He wanted stones between 6 and 12 inches in diameter, sizes that would stack well and create stable walls. He loaded them into a makeshift sled he had built and hauled them uphill, load after load, day after day. His hands blistered and his back ached constantly, but the pile of stones grew steadily beside his chosen cabin site. Dutch Henderson visited in mid-August. He was a loud, opinionated trapper who worked territory north of Elias's claim and considered himself an expert on mountain survival. He saw the massive pile of river stones and started laughing before he even dismounted his horse. "You building a fort or a cabin, Tanner?" he called out. "That's enough stone for half the chimneys in Wyoming." Elias explained his plan calmly. 2 chimneys instead of 1. Dual flue system to create heat circulation. Thermal mass to store and radiate warmth. The secondary chimney positioned to draw cold air from the floor and sleeping area, creating convection that would distribute heat throughout the cabin. Dutch listened with increasing amusement, then shook his head. "1 chimney barely works and takes 2 weeks to build. You're telling me you're building 2? That'll take all summer. You'll miss prime trapping season for a theory." Martin Gresham arrived a week later. He was older than most mountain men, 43 years old with 14 winters of experience in the Rockies. He had survived everything the wilderness could offer and considered himself practically educated in frontier realities. He examined Elias's stone pile and the foundation trenches Elias had begun digging for his dual chimneys. "This is grief talking, Elias," Martin said quietly. "Robert's death wasn't about cabin design. It was about cold that kills no matter what you build. You can't engineer your way out of winter." Elias tried explaining the physics Wilhelm had taught him. Thermal mass, convection currents, air circulation patterns. Martin cut him off. "Heat is heat. More chimneys don't make more heat, they just make more work. He rode away shaking his head, and within 2 weeks, every trapper in the region had heard about Tanner's folly. The man building 2 chimneys because he thought he was smarter than everyone who had come before him. Elias ignored them and continued working alone. Building the first chimney began in early September of 1835. Elias started with the foundation, digging down through topsoil until he reached solid ground approximately 2 feet below the surface. He filled this trench with his largest stones, creating a base that would support the massive weight above. The foundation extended 3 feet square, larger than the chimney itself would be, distributing weight across maximum ground contact. The mortar was critical. Wilhelm had taught him the proper mixture, 3 parts sand to 1 part clay, with crushed limestone added for binding strength. Elias burned shells and bones he had collected to create crude lime, then ground it into powder using flat stones. He mixed batches carefully, testing consistency by pressing samples between his fingers. The mortar needed to be thick enough to support stone weight, but wet enough to fill gaps completely. He laid stones in courses, starting with the largest at the bottom. Each stone was positioned carefully, with its flattest face oriented outward for stability. He selected stones that fit together naturally, minimizing gaps and maximizing contact between adjacent pieces. The mortar went between each stone, packed firmly into every space. He worked slowly, placing perhaps 20 stones per day, allowing mortar to set before adding weight above. The chimney walls were 18 inches thick at the base, tapering to 12 inches at the top. This taper provided structural stability while reducing weight at height. The interior flue measured 14 inches square, large enough for good draft but not so large that heat escaped wastefully. Elias shaped the flue carefully, maintaining consistent dimensions as the chimney rose. Any narrowing or widening would disrupt airflow and reduce efficiency. At ground level, he built the firebox where wood would burn. The firebox was 2 feet deep and 20 inches wide, constructed from his flattest stones arranged to create a level floor and vertical walls. He angled the back wall slightly forward, creating a smoke shelf that would reflect heat into the room while preventing downdrafts. This detail came from Wilhelm's teaching, a refinement that separated functional chimneys from excellent ones. The chimney rose slowly through September and into October, 3 feet high, 5 feet, 7 feet. Elias built scaffolding from logs as the structure climbed above his reach. He mixed mortar daily, placed stones with obsessive precision, and checked vertical alignment constantly using a plumb line made from string and a river stone. Any lean or deviation would create structural weakness that could fail during winter's freeze-thaw cycles. By late October, the first chimney stood 10 feet tall, extending well above where the cabin's roofline would be. The structure weighed approximately 2,000 pounds and represented 6 weeks of continuous labor. Elias built a temporary roof over it to protect the mortar from rain while it cured. The stone mass was already storing daytime sun warmth and radiating it into the evening, demonstrating the thermal principles Wilhelm had described. 1 chimney completed, 1 remaining, and winter was approaching fast. Elias began gathering stones for the second tower immediately. The second chimney began in early November, later than Elias had planned. Snow was already falling intermittently in the high country, and most trappers had finished their winter preparations weeks earlier. But Elias understood that his entire system depended on both chimneys working together. 1 chimney would heat the cabin. 2 chimneys would create the circulation that kept every corner warm. Building only 1 would prove nothing and save no one. The second chimney's foundation went in faster than the first. Elias had developed efficient techniques through his initial construction experience. He knew exactly how deep to dig, how to mix mortar for maximum strength, how to select and position stones for optimal stability. What had taken days during the first chimney now took hours. But the second chimney served a different purpose than the first, and its design reflected that difference. The first chimney was positioned centrally to heat the main living area, its firebox designed for sustained burning with large logs and long-lasting coals. The second chimney was positioned near the cabin's far corner, where his sleeping platform would be built, where cold air naturally pooled, where Robert had frozen to death in the loft above a heated room. The second firebox was smaller, only 16 inches wide and 18 inches deep. Elias wasn't trying to create maximum heat output. He was trying to create airflow. The smaller firebox would burn smaller wood, producing less flame but maintaining consistent draft. The key was positioning. By placing this chimney at floor level in the coldest part of the cabin, it would draw cold air directly into the fire, heat that air, and exhaust it up the flue. The rising hot air would create suction that pulled more cold air from the floor, establishing a continuous circulation pattern. Wilhelm had explained this principle using hand gestures in the air, showing how warm air rises and cold air falls, creating natural convection if properly channeled. A single chimney disrupted this pattern by pulling air straight up and out. Two chimneys could harness it, turning the cabin into a thermal circulation system where cold air was constantly being drawn away and replaced with warmth. Elias built the second chimney through November as temperatures dropped and snow accumulated. His hands cracked and bled from the cold and constant moisture of mortar mixing. He worked shorter days as daylight diminished, sometimes placing only a dozen stones before darkness forced him to stop. The physical cost was enormous, but the structure climbed steadily upward. 3 feet, 5 feet, 8 feet. By early December, the second tower matched the first in height, standing 10 feet tall with its flue extending above the future roofline. Two massive stone chimneys now stood on Elias's building site, separated by 8 feet, positioned precisely according to the calculations he had sketched in his notebook. Each weighed approximately 2,000 pounds. Each had consumed 6 weeks of brutal labor. Together, they represented a summer and fall of work that could have been spent trapping, the most productive season completely sacrificed to an unproven theory. Elias began building the cabin walls between the chimneys. The cabin walls went up quickly compared to the chimney construction. Elias used standard log building techniques, notching corners and stacking logs to create walls 14 feet long and 12 feet wide. He positioned the structure so both chimneys penetrated through the roof at calculated points, the primary chimney serving the main living area, the secondary chimney positioned near where his sleeping platform would be built. The logs were chinked carefully with moss and clay, and a solid door was hung using iron hinges he had purchased at Fort Laramie. The interior work was where Elias's system came together. The primary fireplace occupied the center of the main wall, built directly into the base of the first chimney. The firebox was large and deep, designed to burn substantial logs that would produce sustained heat throughout long winter nights. Elias lined the firebox with flat stones that would absorb and radiate heat even after flames died down. The opening was positioned at comfortable height for tending fire, while sitting or standing. The secondary fireplace was radically different. Elias built it low, with the firebox opening only 10 inches above the floor level. This placement was intentional. Cold air sank to the floor in any structure. By positioning the secondary firebox at floor level, it would draw that cold air directly into combustion. The firebox was smaller, designed for burning kindling and small branches rather than large logs. The goal wasn't maximum heat output, but consistent draft that would pull cold air continuously from the lowest parts of the cabin. Between the two chimneys, Elias built his sleeping platform 18 inches off the ground, positioned directly in the path of air circulation between the two fireplaces. The platform was constructed from split logs, creating a solid surface that would stay warmer than the floor. Storage space beneath the platform would also benefit from the circulating warm air. He built shelves along the walls, a small table, and various hooks for hanging equipment. But the critical element was testing the system. In mid-December of 1835, with snow already deep outside, Elias lit fires in both fireplaces for the first time. The primary fireplace caught easily, flames rising and draft pulling strongly up the main chimney. The secondary fireplace required more attention, smaller wood and careful arrangement to establish draft. But within 20 minutes, both chimneys were drawing properly and smoke rose from both flues. The effect was noticeable within an hour. Heat from the primary fireplace radiated into the main room as expected. But unlike his previous cabin, the corners didn't remain cold. Air was moving. Elias could feel it, a gentle current flowing across the floor toward the secondary fireplace, rising through that chimney while warm air from the primary fireplace spread throughout the space. He placed his hand near the floor in the far corner. Warm. Not hot, but genuinely warm. He hung his thermometer near the door and monitored temperature throughout the day. By evening, with both fires burning steadily, the interior temperature held at 48 degrees while outside temperatures dropped below zero. The system worked. January of 1836 brought the test Elias had been preparing for. Weather signs appeared in early morning on the 9th. The sky took on a peculiar flat gray color that experienced mountain men recognized immediately. The wind shifted to the northwest and picked up speed throughout the day. Birds disappeared. The air carried that particular metallic smell that preceded serious storms. Elias had seen these signs before. A blizzard was coming, and it would be severe. He spent the afternoon hauling firewood from his covered stockpile into the cabin. He stacked wood along the walls until he had enough fuel for at least 5 days of continuous burning in both fireplaces. He filled his water containers from the creek before it became inaccessible. He secured his traps and equipment. By late afternoon, he was inside with the door barred, both fires burning, ready to wait out whatever was coming. The storm hit at dusk. Wind arrived first, gusting hard enough to shake the cabin walls. Then snow began falling, not the gentle flakes of normal winter weather, but driving horizontal sheets that reduced visibility to nothing within minutes. Temperature dropped rapidly. Elias checked his thermometer. Minus 15 degrees outside. Inside, with both chimneys operating, the cabin held at 52 degrees. The blizzard continued through the night and into the next day. Wind howled constantly, driving snow into every crack and gap in the cabin's exterior. Elias maintained both fires, feeding the primary fireplace with substantial logs every few hours, keeping the secondary fireplace burning with smaller wood that created steady draft. He could feel the system working. Warm air circulated continuously. The sleeping platform remained comfortable. The corners stayed warm. Most critically, the floor temperature never dropped into the dangerous range where cold could seep into blankets and bedding. By the second day, the storm had intensified. Outside temperature reached minus 30 degrees. Elias checked his thermometer every few hours, documenting what was happening. Interior temperature fluctuated between 50 and 56 degrees depending on how recently he had fed the fires. The massive stone chimneys were performing exactly as Wilhelm had described. They absorbed heat during active burning, stored it in thousands of pounds of thermal mass, and radiated it back slowly during the hours between feedings. On the third day, the storm reached its peak intensity. Wind speeds increased to the point where Elias could hear individual gusts striking the cabin like physical blows. Snow piled against the walls, eventually reaching halfway up the door. Outside temperature dropped to minus 32 degrees, the coldest Elias had ever recorded. He fed both fires carefully, maintaining steady heat without waste. Inside, wearing a single layer of clothing, Elias sat at his table and ate a meal of dried venison and cornbread. The thermometer read 54 degrees. He was comfortable. Not just surviving, but genuinely comfortable. In conditions that would have killed him in a standard cabin, he was warm enough to sleep without fear, to function normally. to wait out the storm with confidence. The blizzard broke on the fourth morning, wind dying and snow stopping as suddenly as it had begun. James Pritchard arrived at Elias's cabin on the afternoon of January 14, 1836, 2 days after the storm cleared. He was riding slowly, moving like a man who had been hurt, and when he dismounted, Elias could see frostbite damage on his face and hands. Pritchard was an experienced trapper, 31 years old with 8 winters in the mountains. He wasn't careless or unprepared, but the storm had nearly killed him anyway. Elias brought him inside and made hot coffee. Pritchard sat near the primary fireplace, shivering despite the warmth, and told his story. He had weathered the storm in his cabin 12 miles northwest of Elias's location. His cabin was solid construction, built 2 years earlier with a good stone chimney. He had plenty of firewood. He had kept his fire burning continuously throughout the entire storm, feeding it constantly, doing everything right. It hadn't mattered. By the second night, his cabin interior had dropped to 20 degrees, despite the fire burning hot enough to make his chimney stones glow. By the third night, he couldn't get the temperature above 18 degrees, no matter how much wood he burned. He had piled every blanket and fur he owned onto his sleeping platform and huddled underneath them, wearing all his clothes, and still nearly froze. His water froze solid inside the cabin. His breath created ice on the interior walls. He developed frostbite on his fingers and toes, despite never going outside. When the storm broke, Pritchard had emerged into daylight, knowing he had barely survived. He had heard about Elias's dual chimney cabin from other trappers who called it Tanner's Folly. He decided to see for himself if the system actually worked or if the whole thing was wilderness mythology. Elias showed him the thermometer readings he had documented throughout the storm. Exterior temperature, minus 32 degrees, interior temperature, 54 degrees. A difference of 86 degrees between outside and inside. Pritchard studied both chimneys carefully, examining the firebox designs and positioning. He placed his hand near the floor and felt warm air moving. He stood in the corners and felt heat instead of cold. He climbed onto the sleeping platform and understood immediately why the positioning mattered. The secondary chimney drew cold air away before it could pool and create dangerous zones. "How much warmer?" Pritchard asked. Elias did the calculation based on their documented interior temperatures during the same storm. 36 degrees warmer than your cabin, maybe more. You're 18 degrees versus my 54. Pritchard sat significant for a long moment, looking at his frostbitten hands. 36 degrees is the difference between dying and sleeping comfortably. That's not a small improvement, Tanner. That's survival. He asked if Elias would help him build a similar system. He offered to pay in furs, in labor, in whatever Elias wanted. Elias agreed to help, not for payment, but because he understood exactly what Pritchard had experienced. He had found Robert frozen in conditions that shouldn't have killed a prepared man. The problem wasn't the cold outside, it was cabins that couldn't hold heat inside. Elias helped James Pritchard build a dual flue system in the spring of 1836. The work took most of April and May, gathering stones from riverbeds, mixing mortar, laying courses with the same obsessive precision Elias had learned through his own construction. Pritchard's cabin became the second structure in Wyoming Territory to use the system, and when word spread that he had survived the following winter without incident, other trappers began asking questions. By 1838, 5 more dual chimney cabins had been built across the northern Rockies. The technique spread slowly because the labor investment intimidated most men. Building 2 massive stone chimneys required months of work during seasons when trappers needed to be harvesting furs. But those who had experienced life-threatening cold, or who had lost partners to winter exposure, made the investment. Dutch Henderson, who had mocked Elias's stone pile 3 years earlier, built a dual flue cabin in 1839 after spending a winter in constant misery despite a roaring fire. Owen McCready, who operated a small trading post near the confluence of the Powder and Tongue rivers, started calling the innovation Tanner's Towers in conversations with trappers passing through. The name stuck. Men would mention they were planning to build Tanner's Towers, or they had seen a cabin with Tanner's system, or they were looking for someone who understood the positioning principles. Elias never promoted his technique or claimed ownership, but his name became permanently attached to the innovation anyway. The broader impact revealed itself over years rather than months. Winter mortality among trappers in the region declined noticeably after 1838. Exact numbers were impossible to determine because wilderness deaths often went unreported, but veteran mountainmen noticed the change. Fewer empty cabins in spring, fewer stories of experienced men found frozen despite adequate firewood. The improvements weren't dramatic enough to transform frontier survival, but they were real enough to matter. The Rocky Mountain fur trade collapsed between 1840 and 1845. Beaver populations had been trapped to near extinction in accessible areas, and fashion had shifted away from felt hats toward silk, destroying demand for pelts. Trappers left the mountains in steady streams heading to Oregon, California, or back to eastern settlements. Elias left in 1846, traveling west with a group of settlers bound for the Willamette Valley. He purchased land near Salem, Oregon Territory, and established a small ranch. He married Catherine Morgan in 1848, the daughter of a neighboring farmer. They had 4 children who grew up knowing their father had once been a mountain man, but never fully understanding what that life had entailed. Elias rarely spoke about Robert Calloway or the winters in Wyoming. The past stayed in the past. He died in 1873 at 62 years old, buried in a small cemetery outside Salem. His gravestone listed his name, dates, and the word rancher. Nothing about chimneys or innovations or lives saved. But in the mountains, stone towers still stood, weathered but functional, silent testament to what one man's grief and determination had built.